Welcome to this session on integrating energy and mobility. We will look at the needs, the synergies, and some examples. My name is Oliver Lahr, and I'm based at the Wuppertal Institute. I will hand over later to my colleague Alex Körner from UEMI. Today, we are still heavily dependent on fossil fuels in our transport sector. Over 94% of transport energy is derived from petrol products such as diesel and petrol. And over 23% of the global energy-related greenhouse gas emissions are coming from the transport sector. So when looking at the decomposition of the energy in the transport sector, the carbon intensity of the fuels or electricity or hydrogen, as well as the energy intensity of the vehicles, is quite essential. In particular, when we're looking at the growing fleet of vehicles on the road. This includes cars, trucks, but also two-wheelers, aviation and maritime as well. For example, between 2005 and 2019, the global passenger car sales have increased over 40%, with the most significant increase coming from developing Asian and African countries. China had an increase of over 400% and India of almost 170% over that period. Similarly, the demand for fossil fuels for transportation has increased drastically over the last years, while other sectors, such as the residential area, have stabilized their demand for fossil fuels. This does not just reflect on transport CO2 emissions, but also on the exposure to oil price volatility, so rapidly changing oil prices in the global market. But also the CO2 emissions are increasing from the sector steadily despite all the efficiency gains over the past decades. Today, the transport sector accounts for 8.2 gigatons of CO2 emissions. But not only that, over 4 million people die prematurely every year from ambient air pollution, which comes to a large part from the transportation sector in urban areas. Similarly, in many of our cities, people are losing lots of money, and the economies are suffering from urban congestion. It is estimated that between 1 and 10% of the national's GDP can be lost in urban congestion depending on the urban situation. 1.3 million people die on the road every year. While some of those aspects can be addressed with electric mobility, not all of them can. This section is focusing on electric mobility, but please also attend our other sessions on urban planning and development more broadly, where safety and other issues will be addressed. The global electric vehicle stock is increasing rapidly over the last years. Incentives that are provided to shift to electric vehicles have increased, and that has boosted the sales of electric vehicles. In 2010, there were around 17,000 electric cars globally. In 2019, that grew to over 7 million. The markets with the highest electric vehicle uptake, for example China, India and Japan, but also the US, are those regions that combine vehicle CO2 emission regulation, strong incentives and taxation. China has consistently applied strong fiscal incentives and has adopted new energy vehicle quota schemes. Similarly, California and Europe are pursuing similar paths. As of 2019, the global EV stock consumed about 80 terawatt of electricity, which is about 40% more than the year before. That clearly indicates that while the fleet of electric vehicles is growing, the electricity sector and the decarbonization of such needs to follow suit. My colleague Alex Kerner from Human Environment will now take you forward in integrating energy and mobility on concrete examples of what that means.